Hello everyone, welcome back. Here is Ali Talabi and this is lesson 2 from module 12, portfolio management. So in this lesson, we'll talk about modern portfolio theory, and also I will show you how we can construct a risk-free portfolio for sure for two assets. And I will show you that actually, at least on the paper, that's a reality, so we can make it happen. And towards the end of this lesson, we'll talk about two different type of risks, market and unique risk, and I will distinguish between those and will show you what are the differences. So let's start our session today. So let's talk about the modern portfolio theory. So when it comes to investment, for sure you have several options. So we are talking about the two asset investment. So you can define or invest on any portion of these two assets. So you can combine 50% of asset A, 50% of asset B, or you can go with any other combination. So these are called your investment opportunity set. Which provides, these portfolios are providing different levels of standard deviations and different levels of expected return. Among all these portfolios you have, the one which provides you the highest return for the given level of risk, or the lowest risk for the higher for the given level of return, are called efficient portfolios. And the ones which provides you the portfolio with the lowest volatility is called minimum variance portfolio. To explain this modern portfolio theory, which was actually argued by Harry Markowitz in 1950s, let's look at the relationship between the standard deviation and expected return. So let me just explain these concepts in a curve. So let's see how actually this MPT work. So you have two assets, so you can invest either 100% on bonds. So that's your risk-free asset. So we're talking about mainly about T-bonds, or you can go and invest 100% on stocks, or you can go with any other combinations. So 20%, 80%, 50-50, different combinations. And these different weights are giving you different levels of risk and expected return. Any of this sign here, as you see, any of these spots here are showing different combinations. So these are the portfolios that you can choose based on these different combinations. For example, this one is providing 10% standard deviation and almost 6% return, and so on and so forth. Now, let me ask you this question. Will you choose this portfolio, 10% standard deviation, 6% return? For sure not. Why? Because with the same level of risk or standard deviation, you can go up and choose another portfolio which provides you almost 10%. And we argued under MPT, the argument here is that you will go and choose the portfolio with the higher return with the same level of risk, or the lower risk with the same level of return. So you should ignore the first one and you should go upward. So with the same argument, we should ignore all these portfolios because these are inefficient portfolios. So starting from the most left side portfolio, as you see here, going upward, you can choose any of these portfolios because again, these are efficient portfolios. They provide you the higher return for the same level of risk. So we call this efficient portfolio set. And the one which is on the most left side, it's called actually the MVP, or the minimum variance portfolio, because it provides the lowest possible volatility which you can have out of these combinations. Now, let's look at the example and see that how actually this MVP and the efficient portfolios are working. So here is an example which actually shows how the modern portfolio theory is actually works. So let's look at this example. Let's assume your expected return for asset A is 15%, for asset B is 10%. The standard deviation for asset A is 40%, standard deviation for asset B 30%. Now, we can go with different correlations, and we can define different level of correlation. So here I'm assuming assets A and B, they are negatively correlated, and this negative correlation is perfect, so -1 or -100%. So if that's the case, here are the combinations. So we have the portfolios here with different combinations, as you see here, based on different weights. you can calculate the different portfolios, different level of expected return and standard deviation. So as I mentioned, these portfolios are inefficient portfolios because you can find a higher return for the same level of risk. So starting from the most left side, we will see the efficient portfolio set. So we can choose any of these portfolios. And the one which is here, it's your minimum variance portfolio. But maybe you say, Ali, I see in this example that for the MVP, the minimum variance portfolio, actually, it seems your standard deviation is almost zero or just zero. However, the expected return is 12%. So it seems you were able to form a risk-free portfolio under this specific scenario, just combining two assets. Maybe you say, Al, is it actually possible to have this type of portfolio? And the answer here is yes, we can actually, at least on the paper, to form a risk-free portfolio. How we can do that? So let's talk about that. So our goal here is to form a risk-free portfolio when we have two assets. So there should be two conditions. So we need to fulfill two conditions. I'm sure that you know the first one. The first one is very straightforward. To form a risk-free portfolio, you need to have the correlation of -1. So two assets should be perfectly negatively correlated. So one is when one is going up by 10%, the other should go down by 10%. So that's the first condition. What about the second condition? So for the second condition, I need to provide a bit more information here. So here we need to focus on the weight. I mentioned the weight is very important when it comes to risk of the portfolio. So we learned that we can calculate the variance of the portfolio by using this formula. So it's not a kind of a big deal. We just learned that we can calculate the variance by using this formula. The correlation plays an important role. We assumed here the correlation is -1. So let me just substitute correlation with -1, which means the sign will switch to negative. So that's a negative sign. So I can rewrite this formula because we know that when you have actually A2 plus B2 minus 2AB, this is same as A minus B squared. We know that. Correct? And what is our A here? Let's assume your A here is WA sigma A, and your B here is WB sigma B. So I can replace this formula for variance with this new one. So the variance of the portfolio becomes WA sigma A minus WB sigma B squared. Now I'm looking for the standard deviation. So the standard deviation should be actually the square root of the whole thing on the both left and right side. But remember, since this is the minus, the number might be negative. But we know there is no negative standard deviation. That's why I'm using the absolute sign here. So the standard deviation of portfolio, if the correlation is -1, should be WA sigma A minus WB sigma B. Now, you want us to form the risk-free portfolio. What does it mean? It means the standard deviation of the portfolio should be 0. So that's our assumption here. The standard deviation should be 0. Now, since this is 0, I can get rid of the absolute value sign. So I can say, okay, WA sigma A minus WB sigma B should be 0, which means WA sigma A should be same as WB sigma B. In other words, the ratio of weights of two assets should be same as the ratio of a standard deviation of those assets in the reverse order. So WA to WB should be sigma B to sigma I. Now, why this is a kind of important to us? Because this is the second condition. If you can set the weights of two assets in a way which are based on the standard deviation of two assets, actually you can form a risk-free portfolio. So if you know the standard deviation of two assets, and if you know the correlation is -1, based on that you can calculate the weight, and it shows that actually how much you need to wait on how much you need to invest on each asset to get a risk-free portfolio. So this is the second condition. You can actually form a risk-free portfolio. Now, Before wrapping up and finishing this lesson, let me talk about the market versus unique risk. Why this is kind of important? Because we learned that diversification, it means that you are actually reducing the risk, you are actually minimizing your portfolio risk. So maybe you say, Ali, so let's go and invest on 100 stocks or 200 assets, and we just eliminate the total risk. This is not true. Why? Because actually, when we are talking about the standard deviation, a standard deviation measures the total risk, including the unique risk and the market risk. So it captures any volatility, it captures any fluctuations, regardless of the firm risk, the unique risk, the market risk. Maybe you say, Ali, what are the differences between the unique risk and the market risk? The unique risk, which is also called the firm-specific risk or non-diversifiable, diversifiable risk, is the risk which you can get rid of by adding more assets to your portfolio. Now, let's look at this graph. And it's showing the number of assets in your portfolio, and the vertical axis showing your standard deviation or total risk, as we call here. So you see, as you're adding more assets, to some degree, you can reduce your risk. After adding like 20 stocks or 25 stocks, you see that the total risk is not reducing anymore. This is the risk which we call market risk or non-diversifiable risk. Which means, or also called systematic risk, which means that there are some risks, some factors which are out of your control, related to the market, related to economy, related to inflation. There are many other factors which they impact on the risk of your investment, and they are not related to that specific firm. So you cannot get rid of those. You need to accept that risk. So it is called market risk. So how we measure the market risk? The market risk, we cannot use the standard deviation for that. Why? Because the standard deviation includes the total risk. So if you are the good manager, if you are able to diversify your portfolio in a good, efficient way, as we learn, so the firm specific or the unique risk shouldn't be relevant here. You should remove that from your calculation, and you need just to focus on the market risk. How we measure market risk? We use beta to measure the market risk. Maybe say, Ali, what is beta? In the next module, we'll talk about beta, and I will show you how to measure beta using a real case example, and how we actually apply beta in the concept of CAPM or capital asset pricing model. Till then, thank you very much. Have a wonderful day. Talk to you soon. Here is Ali Talabi. Take care. Stay safe.